Within the refrigeration cycle, the compressor acts as the mechanical heart, pumping refrigerant through the entire system and carrying the majority of the workload. But this component operates under one strict, non-negotiable law. It is engineered to move gas and absolutely nothing else. On this diagram, entering the left side of the compressor is a light blue dotted line, representing pure, low-pressure superheated vapor. The compressor squeezes this gas, increasing its pressure. It leaves the right outlet as high-pressure superheated vapor. As long as the refrigerant arrives as a pure vapor, the system runs safely. The lifespan of the compressor depends entirely on the physical state of the refrigerant the moment it reaches that inlet door. The primary cause of system failure occurs when that rule of vapor is broken and liquid enters the compressor. This animation shows the internal conflict. While gas easily compresses, liquid physically cannot be compressed. When the piston tries to squeeze a solid block of liquid, the mechanical force has nowhere to go, resulting in bent connecting rods and shattered internal components. To find the source of that liquid, look upstream to the evaporator coil. This is where the refrigerant changes from a liquid back into a vapor. Inside, it is in a saturated state, a volatile transition zone where it actively boils, absorbing heat. A dangerous condition arises when the evaporator fails to absorb enough heat to boil off 100% of that liquid. If the boiling process is incomplete, the remaining liquid escapes the coil and creeps down the suction line, traveling directly toward the compressor. When that raw liquid reaches the compressor, it creates a system-killing event known as liquid flooding. Ultimately, a mechanical failure at the compressor usually traces back to a breakdown in the boiling process happening further upstream. Technicians prevent these failures by monitoring superheat, the primary diagnostic metric used to prove that the compressor is receiving only vapor. Superheat represents the extra heat absorbed by the refrigerant after every drop of liquid turns to gas. It is the temperature rise once the boiling process is completely finished. To calculate this, subtract the evaporator saturation temperature from the actual suction line temperature. Every system has a specific target for this number. If liquid reaches the compressor, would the actual superheat be higher or lower than that target? The answer is lower. A low superheat confirms the evaporator is overfed, meaning liquid escapes before boiling off completely. This condition is typically caused by a system overcharge, an overfeeding expansion valve, or restricted indoor airflow preventing heat absorption. Protecting the system's most expensive component requires mastering superheat, ensuring that only pure, superheated vapor ever reaches the compressor inlet door.